Good evening, audience, and welcome to the classroom. Today, we have also come to continue with you looking at the study of matrix and operations in matrix. Do remember that in some of our previous videos, we already had looked at the concept of a matrix in totality and equally considered some operations like addition of matrices, subtraction of matrices, multiplication of matrices, especially as it concerns the scalar multiplications. We equally had considered some illustrative examples to showcase the addition, subtraction, and scalar multiplication of matrices. However, there are still some questions that once one comes across them, even though you may have participated in our classes, you may still begin to ask yourself some questions how you go about them. Because these are questions that perhaps over the years, some exam bodies have been asking students. So we have some questions which we have drawn out and deemed it fit to solve them with you so that whichever way that they come from, asking you some questions on matrix operations that you might not be thrown off balance. Today we have just two questions to solve with you about matrix multiplication and addition combined together. So permit me to call the questions up on the board while we solve with you gradually to the best that you can easily have on matrix. The question says, and I write. So that is question number one. Question number one. It says if A is defined as a 2 by 2 matrix 0, 3, 2, minus 4, and K A is defined by 0, 2B, 3A, and 24. Find K, A, and B. That is just the question. The question says, and I read, if A is a 2 by 2 matrix defined with the following entries, and Ka is also a matrix defined with these entries 2 by 2, we should find the values of K, A, and what? And B. We can only solve this problem successfully if we know what we call scalar multiplication of a matrix. So I'm going to call that knowledge up. We solve it together, and before we know it, we are at the values of A, B, and what? And K. So as a way of solution, permit me to divide this board this way. So as a way of solution, I come. I was given A to be this matrix. So if I want to find Ka, I will say that my Ka is at this solution. My Ka equals. Here is my K, I'll write my K. What is my A? My A is 0, 3. So I have here 0, 3. I have here what? 2. And I have here minus what? 4. Then I'll close it. This equals. Of course, when you are considering scalar multiplication, which is a constant behind the matrix, or whatever thing behind a matrix that is used to multiply that matrix. It implies using that value to multiply all the entries of what of the matrix. That's what we call scalar multiplication. So I'm going to take this k and use this k to multiply all the entries of this matrix. And by doing so, what I'll have becomes that I open this and I open this. I will say k times 0 is 0. K times 2 is 2k. So here is 2k. K times 3 is what? 3k. And then k times minus 4 is minus 4k. So my Ka is given like this, based on the information they gave me on the nature of what? Of A. So I only use the K to multiply this matrix what A, and I arrived at this. However, in the question, the earlier had told me that Ka equally is given as this. So if this is Ka and this is Ka, it means that this quantity and this quantity are the same thing, in as much as Ka and Ka are the same thing. So I will now say if, which of course is true, this my Ka here equals this my Ka which they give me. It implies that this quantity is equal to this quantity. That is the implication. So I'm going to say it implies that this quantity, it implies that this, which is what? 0, which is what? 2 what? K, which is what? 3 what? K, which is what? Minus what? 4, is equals to, this is the value, which is what? 0, which is what? 3 what? A, which is what? 2 what? B, and which is what? 20 what? 24. I'll close it up. So this is minus 4k, sorry. Then we now go ahead. Whenever two matrices are said to be equal, what it implies is that the corresponding entries of the matrix equally have to be equal. This is a matrix equated to each other. It means that these corresponding entries must be equal. And if you watch, here is 1, 1 of this matrix, this is 1, 1 of this matrix. So this quantity that is here is supposed to be what is here. And if you watch, this is 0 and this is 0. So if this is true, it means that this quantity equally is equal to this quantity. It also implies that this quantity is equal to this quantity, and implies that this quantity is equal to this quantity. So what am I going to have? I will now be able to say, therefore, here my 0 equals 0. See, 0, of course, you know is equals what? 0. I go ahead, I come over here. My 2k is equals to 3a. So I have my what? My 2k equals what? 3 what? A. I don't know the value of k, I don't know the value of ka. So I can't determine them for now. Then I come down here. 3k should be equals what? 2b. So 3k equals what? 2 what? B. I equally don't know the value of k nor the value of b, so I can't evaluate it. I come down here. Minus 4k is equals 24. So I have what? Minus what? 4 what? K equals what? 20 what? 4. It is from this last one that I can do something significant. What can I do? Here is my constant k, which I do not know. So I can divide both sides, this is k, which I do not know. I divide both sides with the coefficient of what? Of k. So I can say all over minus 4, all over minus 4. Minus 4 will cancel minus 4, and I have that k is equals 4 into itself is 1, into 24 is what? Is 6. But remember that I have minus here. So it becomes what? Minus what? 6. So I have known that my k is minus 6. Because k is minus 6, I can easily come back to any of these equations and begin to substitute the value. Now, I earlier had that, I would say recall that Here I have that 2k is equals to what? 3a. I'll say but my k has been found to be what? Minus 6, which is minus 6. So I will now come wherever place I see this word k, I will put minus 6. And it becomes what? 2 into minus 6 is given as what? 3 what? A. This time this will give me what? Minus what? 12 equals what? 3 what? A. Dividing both sides with the coefficient of A. I will say all over what? 3. All over what? 3. This will cancel this and I'm left with A. 3 into itself is 1, into 12 is 4. Therefore, A is equals to minus what? 4. The same thing applies now for the value of this what? B. If you want to get the value of this B, carry this minus 6 now and substitute here. And then the moment you now multiply out now, that becomes what? And divide with what? 2. It becomes the value of what? Of B. So that is how to go about this kind of problem. As a way of refreshing your mind, they say if A is given as this and Ka is given as this, we should find the value of all these parameters. K, A, and what? V. Or I can even call them what? Variables. Okay? Now what you do is this. You presume as if to say this one doesn't exist and go ahead and do for yourself what you know Ka to be. What you know Ka to be is that anytime you are giving A and you are told to use now K to multiply A, you are going to use that K to multiply this quantity. That was why when I came down here, I said Ka is the same thing as using this K now to multiply this A, which is this matrix. That's what I had here. And when you are using a constant or using a number before a matrix to multiply a matrix, it implies using that number to multiply all the entries of the matrix. That was why I said K times 0, 0, K times 2 is 2K, K times 3 is 3K, K times minus 4 is minus 4K. And when I did that thing, what I did is this. Okay, fine. I've known what my Ka is, and look at what the equality told me that Ka is. So if this Ka here is equal to this Ka here, it implies that this thing which I got here is equal to this. Then we equated it. So if this is equal to this, it implies this. And because they are equal, it means that their corresponding interest must be equal. So that was why this and this is equal here, this and this is equal here, this and this is equal here, and this and this is equal here. Then we now came to the last one and found out that we can use to find the value of K, we can divide both sides with minus 4. And when we did, we had minus what? 6. We substitute down minus 6 here and got A to minus 4. The moment you put minus 6 here, you got your B to either be about minus 9 or thereabouts. So that's how to go about that. I believe you didn't have a problem. If you had, drop your concern in the comment section. Once we come there, we attend to you. So permit me to clean this while we call up the second question. The second question says, and I quickly write that the second question says this. It says number 2 now. That's question number 2. It says find the value of x and y if 2 into 5x y minus 4 6 plus minus 4 1 3 2 equals 6 3 13 and 14. That is the question they gave us. So what we are going to do is to quickly go ahead into solving the problem. How do we go ahead into solving the problem? They say find a value of x and y if this quantity added to this quantity gives us this very quantity. We go ahead as a way of solution. So I will say solution. What I have here, the first one is a scalar multiplication. And when you are having a scalar multiplication, what you need to do is to carry that number outside to multiply all the entries of what? Of the matrix. So let me handle this quantity first. Handling this quantity first, I will say this is equals. So I'll open a bracket, I'll open like a set like this. 2 times 5 is what? 10. 2 times x is what? 2 what? X. 2 times this, I'll open a bracket and say 2 into y minus 4. I'll close the brackets. So 2 times this will give me what? 12. I'll close the bracket. Say plus. I'll open another bracket. Here is minus 4. Here is 3. Here is 1. Here is 2. Close the bracket. They say this is equals. Here is 6. Here is what? 3. Here is what? 13. And here is what? 14. I'll close up the bracket. In addition of a matrix, which is what I have at the left-hand side, when you want to add the matrix, you add the corresponding entries. So I'm going to add the corresponding entries. And by adding the corresponding entries, it's going to be this plus this. This plus this. That's what I should be doing. And that's what we call the addition of a matrix. And by so doing, what I'm now going to have is I'll open a bracket this way. This is 10. This addition here. So I have 10. This addition that is here plus what I have here is minus what? 4. I've come to this. Here is what? 2 what? X. What I have here is what? Plus. What I have here is what? Is 1. I am done with that one. I come over here. What I have here is what? 2 into y minus 4. Close it. What I have here is what? Plus. What I have here is what? 3. I'm done with that one. I come over to what? To this one. What I have here is what? 12. The sign here is what? Plus. What I have here is what? 2. I'll close up the brackets. This is equals. Here is what? 6. Here is what? 3. Here is what? 13. And here is what? 14. I'll close up the brackets. I'll move on. Now, plus minus in mathematics is minus. So this is just like 10 minus 4. So, and of course, 10 minus 4 will give us, 10 minus 4 will give us what? Will give us 6. So we are here. We don't know this value, so we just need to write it the way it is. So we have what? 2 what? X plus 1. We come here. We equally don't know what this value is, so we just need to write it the way it is. So what I have here is what? 2 into y minus 4 plus what? 3. We come here. This is 12 plus what? 2, which is what? 14. So I have what? 14. They told me that this is equals what? 6, 3, 13, and 14. I close it up. Whenever two matrices are said to be equal, it implies that their corresponding entries are what? Are equal. And if you watch, here is 6, here must be what? 6. Must for matrix. Here is 14, must, here is 14. So if here must be what is here, it implies that what is here must be what is here. And if you agree with me, it implies that what is here is 2x plus 1. So I will say, therefore, I have 2 what? X plus 1 equals. Must be what is here, which is what? 3. And if this is true now, I'll have that this is 2x now equals what? 3. This one coming over here minus what? 1. So that I'll be able to have that 2 what? X is equals to what? 2. Then all over what? 2, all over 2. This and this is gone, and x equals. This is 1, this is 1. So x equals what? 1. Now, whatever thing that is here must be what is here. Must. So if that is true, it implies that my 2 into y minus 4 plus 3, which is what I have here, must be equal to what I have here. equals what? 13. And if that is true, of course, this and this are like terms. So what I'm going to do, but let me open this bracket first. 2 times y is what? 2y. What is sign here? Minus. 2 times 4 is what? 8. Plus this what? 3 equals what? 13. This is something like saying you are owing 8, but you have gotten 3. That is minus 8 plus 3 will give us minus 5. So what I have here is what? 2 what? Y minus 5 equals what? This 13 that is over here. 13. So in that case, this 13, this 5 can now go over there. And on going over there, it becomes what? Plus. So what I have becomes what? That this is 2y is what? 13 plus what? 5. 13 plus 5 will give us what? 18. Okay? Which means I have that my 2 what? Y equals what? 18. And of course, therefore, my y is equals what? 18 all over 2, which of course is what? Is 9. So the value of x and y that can make this quantity to be equal to this quantity are 1 and 9. That's how to go about that. Thank you very much for your concern. Stay put. We are not relenting. We are definite. We are resolute that we are going to take you to a point where you begin to like mathematics and statistics. Be patient with us. Try and follow us. Subscribe to our YouTube channels. Begin to participate in the classes. Raise your concern if you have issues. We attend to them. Thank you very much.